Hello everyone. In this video, I'm going to go through the AQA Physics Paper 1 higher tier. This is the specimen paper, question number 3, which is on the topic of energy. The national grid ensures that the supply of electricity always meets the demand of the customers. Figure 2 shows how the output from fossil fuel power stations in the UK varied over a 24-hour period. So in this graph, line graph, you can see the total output, power output in megawatts goes from 0 to about 30, and then it rises further. So between the course of the day, that's 12 midnight. Actually, that's 12, this is noon. So that's 16 is 4 p.m., 20 is 8 p.m. This is midnight. And then Tuesday morning 4 o'clock, and then 8, and each of these sections is 4 hours. From there to there is 4 hours. So as you can see, the power usage, the total power output from the power station starts at about 30,000 megawatts and rises to nearly 40,000, and then goes down. By about midnight, it's at the lowest level, and then it continues till about 4 in the morning, and then rises back to about nearly 40,000 again. Question: suggest one reason for the shape of the graph between 15 and 1800 on Monday. Now, what is happening between 15 and 1800? 1500 is somewhere going to be here. So in between is 12, 1400. So 1500 is here, which is starting there, and 1600, which is over here. So that's 1500, which is 3 o'clock in the evening, and 1800 is 6 p.m. in the evening. Why is the power usage, demand for the power, actually going up? That's mainly because after 3 o'clock, between 3 to 6 in the evening, people are actually going home. Students are actually, kids are going from home to home as well from schools. So the amount of electricity that is being used by customers actually increases rapidly after 3 o'clock. So power output increases to meet the demand due to people returning home from work or from school. Question 3.2. Gas-powered power stations reduce their output when demand for electricity is low. Suggest one time on figure 2 when the demand for electricity is low. They're only asking for one time. They're not actually asking even for a range. So you need to be careful not to give more than one. So the lowest power is around midnight. So you could say 100 hours, and it is roughly about the lowest till about 4 in the morning. So any time between midnight and 4 in the morning as your answer should be fine. So let's say 100, or you could say midnight. Like I said, any answers between 100 and 400 should be fine. The national grid ensures that fossil fuel power stations in the UK only produce about 33% of the total electricity they could produce when operating at a maximum output. Now, why would they only want to make sure that the electricity produced from fossil fuels is only 33% of the maximum power that is needed? Well, for a couple of reasons. One, for environmental reasons. They are trying to reduce the amount of carbon dioxide that is being let out, right? Or you could say they're trying to save the fossil fuel, because remember, fossil fuels are non-renewable. So by making sure that they're only using 33%, that means they could actually, the rest of the 67% could come from other sources like solar and wind. And it also makes sure that they have enough fossil fuel in stock, so that if it's not a, let's say, if it's a rainy day with no wind, then you're not going to produce a lot of energy from both solar and from wind. That means you'll have to rely more on the fossil fuels to generate electricity. So any two of this should be fine. To conserve fuel or to spare capacity to compensate for unreliable renewable sources. Now that's a fancy way of saying to make sure that they have enough fuel when there isn't any wind or sunlight. Or you could say provide spare capacity in case of power station emergency shutdown. Right? So let's say one of the power stations within the area shuts down, so another power station will need to provide more electricity or to compensate for it. Or finally, you could say so as not to make unnecessary environmental impact. Question number 4. A student investigated how much energy from the sun was incident on the Earth's surface at her location. What does incident mean? Now this actually sent word from maths. Now here you can see the transparent lid, and the incident solar ray is basically this parallel rays of sunlight that is falling, and we say it's incident, and it's actually perpendicular to the transparent lid, which is basically means it's falling straight down. She put an insulated pan of water in direct sunlight and measured the time it took for the temperature of the water to increase by 0.6 seconds. The apparatus she used is shown in figure 3. So you've got the insulated pan, water inside, there's a thermometer, and the transparent lid, which means that the heat is not going to escape. The water, if it evaporates, is not going to escape as well. So the heat is going to be basically trapped, heating the water. Choose the most appropriate resolution for the thermometer used by the student. Tick one box. Now you can see in the diagram, the thermometer the student is actually using, as is the bottom bit, the dark end, is actually a glass thermometer. It could be a mercury or an alcohol thermometer. So what is the most appropriate resolution? Resolution is the lowest division or number that you can read from the thermometer, because it's not a digital thermometer. Now analog thermometers, if you were to see it, let me show you what an analog thermometer looks like. And this is what an analog thermometer looks like, and the ones with the red end are alcohol thermometers. So the liquid is actually alcohol. If it was silver, it will be mercury. Now for safety reasons, we don't actually use mercury thermometers in schools anymore. Anyway, how do we actually work out the resolution? This is 0 degrees. Now between 0 and 10, each of these divisions, there's 10 divisions here. So the resolution is the lowest reading that you can actually make. So the lowest reading is 0 point, and that line indicates 0.1. So the resolution is 0.1. Energy transferred to the water was 1050 joules, which is E. The time taken for the water temperature to increase was 5 minutes. That's the time. And it increased by 0.6 degrees Celsius. The specific heat capacity, C, of water is 4200 joules kilogram per kilogram degree Celsius. Write down the equation that links energy transfer, power, and time. So the equation that you'll find in the equation sheet is power equals energy, or you could say energy transferred, divided by the time. Or you could write the symbol equation P equals E over T. Calculate the mean power supplied by the sun to the water in the pan. Now, how do you calculate the mean power? We use this equation that we've just written down on the top. Power equals the energy divided by the time. Now, remember, the time is 5 minutes. This needs to be converted to seconds, so 5. Each minute has 60 seconds, so if 5 times 60 is 300 seconds, so 1050 divided by 300 gives me 3.5 watts. 3.5 watts. So the answer is 3.5. You get a mark for converting the time to seconds and then a mark for the correct answer. Next part. Calculate the mass of water the student used in her investigation. Now, to calculate the mass of water, which is M, you need the equation that links the values that is given above. So they have given us the energy, which is 1050, the time, which is 300 seconds, which you don't really need for this, the temperature change, delta theta, is 0.6 degrees Celsius, specific heat capacity of water is 4200, and mass is what we are trying to find. So the equation that links all of these values except for the time, which you don't really need, let's cross it out. E for energy transferred is equal to the mass multiplied by the specific heat capacity multiplied by the temperature change. So let me substitute the values. 1050 equals the mass multiplied by 4200 times 0.6. Rearranging the equation, mass is equal to 1050 divided by 4200 times 0.6. We put that in a bracket. That gives me a mass of 0.417. 0.417 is the answer. Question 4.5. The student's results can only be used as an estimate of the mean power at her location. Give one reason why. Now, the reason it can only be an estimate is because she's testing it for 30 minutes, and during that, was it 30 minutes? 5 minutes, sorry. During that 5 minutes, it was 300 seconds. So during that 5 minutes, the sunlight could have actually changed. There could have been a cloud could have actually blocked the amount of sunlight received. The sun's position could have actually changed, right? Some of the energy could have actually been lost from the pan, even though there was insulation. So it is not accurate. It is just an estimate for any of these reasons. So you could write down any of these reasons, which is, oops, let me bring that into focus again. There you go. Energy used to heat metal pan is used to heat the metal pan as well as the water. So some of the energy is actually going to go into the metal pan. The energy transfers to the surroundings through the insulation, or you could say it is lost to the surroundings through the insulation. The angle of solar radiation will have changed during the investigation. Even though it's only 5 minutes, it could have changed. The intensity of solar radiation may have varied during the investigation, and that's mainly due to clouds blocking the sunlight, and so on. That brings us to the end of question number 4, and I will see you in in the next video for question 5 and 6.